Welcome to the Deep Engineering Podcast, where we bring you real world insights from the architects, engineers, and authors shaping modern software. I'm Divyan Selvaraj, editor in chief of Deep Engineering, and your host. Today, we are speaking with Kevlin Henney, independent consultant, speaker, writer, and trainer. Kevin works with companies on code, design, practices, and people. He contributes to the Modern Software Engineering YouTube channel and has written for both open and closed source projects, as well as a number of industry magazines and sites. He's also co-author of A Pattern Language for Distributed Computing and On Patterns and Pattern Languages within the Pattern-Oriented Software Architecture series. He's editor of 97 Things Every Programmer Should Know and co-editor of 97 Things Every Java Programmer Should Know. Now, Kevlin's career sits at the intersection of software design and day-to-day development practice, making him a thoughtful voice on how teams actually write, test, and evolve code. And he's here with us today to talk about test-driven development and developer testing, from common adoption pitfalls and persistent myths to how testing shapes design, scales across organizations, and adapts across languages and tooling. We're also going to talk briefly about what AI and new techniques mean for the future of quality. So a very warm welcome to you, Kevlin. Thank you for joining us here today.
Thank you very much for inviting me and for the introduction, Divya.
Brilliant. Let's get started. I'm looking forward to this conversation. Right off the bat, adopting TDD can be tricky, even for seasoned developers. In your experience, what are the main reasons that experienced developers struggle when first adopting TDD?
I think there are different kinds of developers. In other words, they will have different reasons for struggle. At one level, you're asking people to do something different to what they normally do. That's the first thing. That's the first challenge. Just as a human being, that's always going to be difficult. And particularly where you already have a set of habits in place, regardless of how actually effective those are, we always perceive the habits that we have as being comfortable. That's why they're habits. And sometimes we have a justification for that. So trying to get anybody to do something different for something they already do is going to be a challenge. So the more experience you have in this case, actually, the more at a disadvantage you may be, interestingly. If you are relatively new to software development, then everything is fresh and every new idea is more likely to be treated equally by you. But even then, we need to understand that somebody like a novice developer can sometimes, and sometimes we have the issue with people who are kind of in that overlap space, that they're not necessarily formally a developer, but they do a lot with code. So I'm thinking particularly, data scientists and engineers who might not consider themselves to be developers, but say work extensively with Python and associated libraries, NumPy, pandas, and things like that. So they're in the development space, but they don't necessarily have the insight of development culture and concepts there. And often they have semi-effective workarounds that they've done that kind of get them by every day. And the point is that most people, this is the case for most people. And when it comes to testing of any kind, we don't necessarily have as good a story for people in any kind of testing as we do for creating a feature and doing a demo. These ones are very well practiced within software development space, and often videos and books will emphasize these. And there's much less on any kind of testing, let alone TDD. So it tends to be more ad hoc. So when you're trying to get somebody to do something like TDD, which is a very structured workflow, that's your challenge. You're trying to get them to do something different. Then one of the other challenges is often the way that TDD is described. There's a kind of a simple mantra: red, green, refactor. You write a failing test for something, then you make it pass, and then you refactor. And although it's a very simple mechanical description, it's not wrong. It's not very motivating, right? It's just like, why do you want me to write something that doesn't work? It's just, that's not the right mindset. Write a thing that doesn't work and then make it work. That doesn't feel like a motivating mindset. So I think that's another obstacle. And often the examples or the way that TDD is taught makes a lot more sense to somebody who has expertise in it, or when you're coaching alongside somebody, than it does just offering somebody that. It's not compelling. And I'll be the first to say this, although when I do workshops and training courses for companies, I will describe the red green refactor. You need to know that. But then I go into it and I take it apart and I say, what's really going on? And at that point, it becomes easier to motivate. The first thing is you're not just writing a failing test, you're writing something for a behavior that you don't have. And because you don't have that behavior, of course, it's not going to pass. But the goal is not to make it pass. The goal is to write what you want for the new behavior. Then the next motivation is actually a simple constraint. It's the idea that in many cases we can end up yak shaving or just running off into the horizon with complex behaviors. Go, oh, I'll just write everything and then I'll come back and test it later. The idea is that if we do that, we often end up with things that are not necessarily as simple as they should be. And we don't ask ourselves the question, is this what I need? Is there a simpler way to do this? So literally, it's a limiting factor. It's like throttling back the instinct to just like, now I'm going to just throw it all at the screen. Is actually, I'm going to take steps so that I understand every step and I consider it. So it is really a scoping mechanism. The idea is now I'm going to make it pass with something that is no more complex than is necessary, so that I fully understand what the next step is going to be. And I can guarantee this is always working. But I'm also going to give myself the opportunity for refactoring. Now, when explained like this, I'm not going to say that suddenly turns on all the lights, but it does make more sense. And then we move to the next level where we actually say, look, let's forget the red and green. Red and green are side effects. Your real goal is, tell me what you want to have working. Here is a piece of code. It has a certain amount of functionality. You want it to do something else. What does that extra bit look like? Show me an example. And it's just like, well, it should do this. Okay, great. Does it do that now? No. That's why it doesn't. It either doesn't compile or it doesn't pass a test, because you're asking for something new. So a test is a change request. Now, when you do that, a lot of people go, oh, I see. You're writing a change request to yourself. You're saying, I want to have a piece of code that does this, but it doesn't do that yet. But here's a really concrete example of what I want. And now I'm going to work towards that. And I'm done within in a couple of minutes. And I can continue from that. So the point there is it's not simply you're teaching somebody how to test. That's not, although there is a truth in that. You're actually trying to rewire how they think about the very act of coding. And that's hard. That's why you will find it is a skill. It is something worth practicing. And it is a practice that once you have it, you can now draw upon. It doesn't mean you have to do it all the time, but if you've never practiced it, how can you say, oh, that would be appropriate now as a tool or a technique? But we're trying to rewire how people think about the very act of coding, and that is difficult. So you will resistance because of change, but also resistance because it's a fundamentally different way of doing something for which people already kind of have some behaviors.
Right. And I think you've talked a lot about the mindset shifts required, and you said part of it, adopting TDD itself, is a sort of skill. But are there any specific skill gaps you could sort of point out that tend to be the biggest hurdles for developers to not adopt TDD?
Yeah, I mean, honestly, sometimes the problem that in terms of the skills gaps is actually to do with testing itself and unit testing, and that in other words, they don't have a habit of any kind for testing, or testing is something that happens later and sometimes in a mad rush, and so therefore the tests that are written are actually quite difficult to read. And we must regard, and people often have this idea of tests being a second-class citizen. And often you look at tests and you go, well, yeah, they look it, and people create tests that are difficult to maintain, sometimes because they've never been shown what do good tests look like. So for many people, when they're learning TDD, they actually encounter the fact that there's many things that they're trying to learn at the same time. And one of them is, what does a good test look like? And that's an issue. So, pick up on what I just said. It's a specification, or rather, there are many ways of thinking about testing, but the way that we're encouraging here is specify. Your test should be an explanation, a description that captures intent, and it should have an example. The example is the centerpiece. And you want to capture the intent in the name if you have a test that does too much. So it turns out that many of these things are things that people don't already know or don't already do. So there's an additional skill in addition to the workflow is how do you write a good test. The other skill that I would say is often missing is people don't necessarily have a good code sense. And what I mean by that, or a design sense, what I mean by that is that they often don't know what does good code look like? Or when you say, and now refactor, they don't know what to do because although they may have a refactoring menu available to them, although they may know the meaning of the word, they don't actually know what looks better than this. So you end up with code that just gets bigger and bigger with more ifs and whiles. And it's just like, well, this isn't what I had in mind. Where's the simplification? They're not actively looking for simple. And that's a design skill. And that's actually quite difficult to teach. So therefore, it requires, if you're going to make best use of any workflow, and this is not unique to TDD, and what I find is that many workflows, people are not actively looking for a good design. How do I make this simpler? How do I make sure I have less code to maintain in future? Let's put it that way. You want to write less code. Your goal is not to produce more code. It is to produce less code. Your code, that's the most common thing I see is programmers. Yeah, if you want a skill, programmers don't know how to write less code than they need. They often go in with code like that. There is absolutely nothing wrong with writing too much code as your first draft. It's what you do with your second draft. And that's the problem, is that many people don't necessarily have that because they haven't worked alongside somebody, they haven't been shown what that looks like. You can't expect this to be an act of magic. You start learning how to code and suddenly you develop a good instinct for the right balance and structure of a method, of a class, and what an interface should or should not look like to be effective, and what is or is not easy to change. So without it helping people get that sense, almost any workflow you throw at people is going to make things potentially worse. I mean, we see that with AI, that people who don't know how to code produce a lot of code. They need to learn to produce less. You can use AI to produce less. The skill is to produce less to do what you want, because then you have less that can go wrong. You have less to read. This is something that I don't think we get across. And for me, I find TDD helps me with that, because it always kind of reminds me, okay, how now cook it down. You got this, cook it down. You got tests, they work. So you have a safety net. So if you like, there is a skill, which is that very much of a code sense, both for the tests and the body of the code itself.
Right. So we've talked so far about, let's say, a lack of awareness or some gaps in comprehension that sort of lead to an unwillingness to adopt TDD. Let's talk about some misconceptions now. What do you see as the biggest misconception or myth about TDD among developers and teams today?
I don't know that there is necessarily just one, but there are a number of misconceptions, and one of them, one is that it's only something that you can do with new code. Another is that, to be precise, it can only be used on a greenfield project. Another is that if I'm going to do TDD, then I really need to care an awful lot about, I need to do an awful lot of mocking. Another is that your TDD is very much centered on your unit testing framework and things like that. So there are a few things there that I think are fairly common. For some people, there is a misunderstanding as we live and work in an industry where jargon is often thrown around and sometimes it's very imprecise. When some people hear test-driven development, they don't really understand that there's a workflow associated with it. Sometimes they just hear test-driven development in their head, and the way I've seen it described in a number of companies is, oh yeah, we're doing testing. So, which is great. There's nothing wrong with that. They're not doing TDD, and that's not a bad thing. They may be doing absolutely brilliant testing. They may have really comprehensible tests. They may have a structured workflow, but it's not driving what they do. It's the code leads and the tests follow, which is a different workflow, and it's perfectly fine. I'm not here to tell people that TDD is the one true way. It's just we're not perhaps using the right terminology in that case. So sometimes TDD as a term gets experiences a semantic dilution. It becomes just meaning developers are testing, which is great, but we'd like to call that developer testing, just as a sort of general term, rather than TDD, which is a very specific workflow.
Yes, but just digging into that a little bit more, are there any particular false beliefs that sort of really get your goat and you sort of love debunking?
Oh yeah, okay. So there is one. There's one there's one that has two sides to it. So first of all, actually, I'll separate out things. So sometimes when people say, "Oh, we don't do TDD," or "TDD is difficult to do here," or whatever, one of the things I've learned is that actually the person is not talking about TDD; they're talking about unit testing, just unit testing, and they're using TDD to say that. In many cases, when people say, "Oh, we can't do that," actually, what they're saying is we don't do a lot of unit testing. So they're using TDD almost as a kind of like a scapegoat. And it's just like, actually, that's not your problem. Your problem is you're not in a position where you feel comfortable testing, and culturally within your organization, you don't test. And that becomes a reinforcing thing. It's not about TDD at all. It's actually much simpler. This isn't about your workflows. This is about just having any tests or reasonable tests at all. But the thing is, we're also prone to doing these kind of little, so I'm going to pick on something that's actually not from people who don't do TDD, but from people who do TDD. Every now and then you'll hear somebody say, "Hey, TDD is not a testing practice. It's a design practice." And it's just like, no, really, it is a testing practice. And it absolutely is. You end up with a whole load of tests. You are constantly getting feedback from a testing framework. You do end up with that. I know what they're trying to do. They're trying to emphasize the idea that the very workflow is more than simply an act of verification. Okay, so we often have this idea of testing is about verification. And it's just like, that's not false, but it is not the whole truth. Testing can give you more than this. But the point is that if you push things too far to say you have a neat slogan, TDD is not about testing. No, it really is. It's not simply the fact that maybe we could have come up with a better name, but it does have the word test in it. No, you do end up with tests, and it is a way of testing. It is absolute, but that's not the only thing it is. That's the important thing. So for me, it's when people say, "Oh, it's not about testing." No, it is. But it can be about more than one thing. We've got to move away from the idea that there's one solution or one explanation for something. This one stands on 2 feet. Okay, and that's the point. Testing is one of them, and then there is the other. But at the same time, the counterpoint and the reason that people do say this within the TDD community is partly as a slogan because it sounds kind of cool, it's provocative, and it gets people thinking. It's not a true statement. So I always have problems when people use statements that are actually not true just to provoke a discussion. Is that many people do think that TDD is just about testing. So that honestly, that's how I get, at least half of my work is that company says, we want to do TDD. Actually, what they want to do is testing. And I always make sure that I teach people, I encourage people to do TDD, and I very strongly anchor it in TDD because it is a disciplined workflow. You can tell when people are doing it. It's also the most extreme thing they've probably done. So why go on a training course to do what you already do? So I'm going to do the thing that you don't do. And after that, you now have a much broader sense of what is possible. Whereas if I don't do that, you don't truly understand what is possible. But I always make sure that people are aware there are many workflows. But I try to make sure that what they understand is that when we're doing TDD, we are trying to explore ahead. We're trying to clarify what we know. But when I say ahead, I don't mean a long way ahead. I mean just immediately in front of you. Do I understand what I'm actually asking for? Do I know what I want from the code? And sometimes that's a question for, the developer as an individual. If I don't know, then what does that mean? Should I be writing this? Should I go and speak to my product owner? Should I go and speak to one of my colleagues who may know more about the code base than I do? I'm working from a position of ignorance here. The fact that I don't know what I want at this point suggests that I don't have enough knowledge, so I should go to somebody and get some ideas. So the idea is it's this constant checking loop, but it's also where you make certain decisions. And some of the decisions may feel very small, what are the arguments to this method I'm creating going to be? But some of them are actually quite large. Do I really want this service to do all of the things? I'm asking an awful lot from one place. This test feels too large. And that's not actually the test. That's actually the design. The test is this large because the design is causing that. And why does that matter? Because a test is an example of usage. So therefore, in order to use this, it's quite complex to use. So what you're getting is that the test is amplifying more subtle issues in the design. It's throwing them into a kind of like a sort of an enlargement. It's a mirror that amplifies and magnifies, and your job is to sense that and go, the test is difficult to write. Therefore, code that uses this feature that I'm creating will be difficult to write. That's the bit that sometimes people miss, is that another way of looking at it would be usage-driven development. Show me an example of code that you would like to have working. Show me how it works, and let's make it work. And if in order to use relatively simple, to get some simple functionality, I end up having to do complex choreography that pulls in lots of dependencies, and the interface feels very clunky, then you know what? That's nothing to do with the test. The tests have simply told you this is quite difficult to work with. Maybe you should reconsider this. So the idea there, the real lesson there, is that this idea of testing is much more continuous. You're getting constant feedback as to what it feels like. If you like, testing is, in fact, to go back to the question, return to the root of the question, one of the things that does bug me is the way people look at testing as a purely quantitative activity. I got this percentage statement coverage. I have done this many tests, passed this many tests. There's nothing wrong with that. These are numbers that tell you something about what you have built and what you're working on. But there is another side to it, which is qualitative. What does it feel like to write the test? What does it feel like to use the code that I am providing? And if the answer is, yeah, it was quite easy, that's great. If the answer is, it's quite difficult, I feel like I'm having to work against it, and it's quite complex to set up even the simplest piece of functionality, that's a qualitative feedback that tells you I should be improving this. It's almost like having a code review where you have to do most of, you're both creating code and you have to do most of the listening, because your tests are not speaking directly to you, but they are hinting that there may be something up.
Right. And that brings us very nicely to my next question, actually. So there's an ongoing debate about TDD's effects on software design and architecture. Some argue that focusing on small tests leads to fragmented design or lack of big picture thinking. How do you believe TDD influences software design in reality?
I think it goes back to what I was saying about having this kind of design sense or code sense, is that if you are only ever going to think small, then yeah, TDD will have those effects, and you will end up with a fragmentation rather than a cohesive design, which is one of the reasons it's quite important to make sure that you have a reasonable test hierarchy, that you're testing at all levels. And why it is that when you're doing this, you should always be taking the big picture view as well. And this is, I guess, the driving metaphor is used extensively, but when talking about TDD, but these days it's even more appropriate. When I drive, I'm looking. There are three places that I am typically looking. I'm looking at the road immediately in front of me. I'm also looking down at the dashboard to see what my car is telling me, and then I'm also looking at a map to see what the big picture is. And the problem is that I get the feeling that many and this is again not just a TDD thing, I find this with different views, is that I get the feeling that the different roles in development are only ever looking at one of these at a time. So it's like, well, of course, if you're only looking at the dashboard, you're not going to see what's you're going to slam into something in the road in front of you. But if you're only looking at the things in the road in front of you, that doesn't tell you what the bigger picture looks like and what the trends are in traffic, for example. So you're not getting feedback. You're not getting feedback at all these three levels. You're only ever looking at one and ignoring the feedback from the others. So here's the thing: if you end up with if you are using TDD and that has caused you to end up with a fragmented design, that's not TDD's fault. That's your fault. You are making the decisions. The point there is fault is a strong word, so let's put it a different way. That's a learning opportunity. It's like, what is it that I'm not picking up? Because clearly, if I'm writing the code, then what's the difference does TDD make? It causes me to write the code. Well, I'm writing the code. Okay, so what's the thing? Have I focused too narrowly? Am I not every now and then looking up to see what's going on? and looking at the bigger picture. And that's what you learn, is that sometimes, and I know this again independently from TDD, is that many developers do only focus on the thing in front of them. That's very natural to be very detail oriented, and our development environments encourage that. Our IDEs show us the code. They don't show us the big picture by default. There are IDEs that do that, but we are encouraged to, we're not encouraged to step away and step back. And there are techniques for that. One of them simply is to always be in conversation with somebody else, or have repeated conversation. So proper code reviews. I've started calling them proper code reviews because I know that for many people, code reviews are basically pull request comments. That's not a code review. I mean, you can call it what you like, but it's not a code review. A review is an interaction between two or more people that is synchronous. There's a conversation there. And the point there is, this is not a judgment, it's a conversation. It's a conversation about context and situation. You're looking at the bigger picture. But also, whenever you're having design ideas, the idea is, when you are launching into TDD, do you have a vision of where you're going to go? And that's the problem, is that sometimes people don't actually have an idea of where they're going to go. So I often have this thought of, like, sketch out an approach. Now, don't commit yourself to detail. This is not a committed design. It is literally a sketch. And so now, as a sketch, what you're going to do, what TDD is going to do, is it's going to fill in the details. If anybody who does draw, and I do know that drawing is not a very common skill amongst developers. It's one of those things I always ask people, what do they do? Music is very common. Gaming, very common. Certain whether it's computer-based games or board games. These are very common. Okay. Certain sports, very common. Drawing, not very common. But when you draw, you often sketch the form and then you put the detail in. But that detail sometimes tells you maybe the form's not right. So for me, is people often launch in hoping, if they start drawing in the bottom right-hand corner, that a miracle will occur. And if you're a brilliant artist, yes, a miracle will occur. You will produce a great picture. But sometimes people are not looking at the big picture. They always need to be going, like, how is this going to be used? How does this affect that? So for me, I think that we can look at that. So for some people, they say, oh, TDD doesn't do this. No, that's your job. TDD's job is to do the sketching. It is your job as the artist to see the bigger picture and go, oh, I'm drawing the wrong thing, or maybe that needs to be moved, or, to take the feedback. So if you're only taking feedback at one level, that's great. Many people take feedback at 0 levels, but you need to be looking at multiple perspectives. Some of them are closer and some of them are further away. So I don't really accept the criticism that TDD causes this. I accept that there may be a misunderstanding of the role of TDD, that people are sometimes saying, if I do TDD, magic will occur. As I told my kids when they were growing up, there is no such thing as magic. There's you. There's you and a tool and a technique. That's it. If you are misapplying the technique, that's not the technique's fault. So therefore, there's a learning opportunity.
Right. Picking up from that, would you say TDD negates the need for upfront architecture, or do we still need a balance of architectural planning alongside TDD?
I think the alongside is important, because I think the problem with the term planning is that sometimes people think that architecture is done up front. So I'm definitely against architecture up front, because architecture is about big decisions that are hard to change. When you do stuff at the beginning of a development, you are at a point of the minimum knowledge. You will never know less than you do now. And then you can take big decisions that are going to affect the rest of this development for months and for years. That's not responsible. So purely from a point of view, that's not a responsible approach. So what we need to do is adopt a slightly different mindset. When we are establishing certain architectural decisions, like how we partition a system, how we break things up, do I put this in a separate service of its own, or is this a module within a service? All of these kinds of questions. These are questions. And people often, I think we're in a rush to find answers. And it's just like, no, really skilled software developers don't get better at doing answers. They just get better at doing questions. Learn to deal with your questions, and then you do things that help you answer those questions. To put another way, I'll quote Tom Gill, but basically he describes architecture as a hypothesis. It's not a plan, it's a hypothesis. Here is a set of things that we believe will work for us, but a hypothesis is there to be tested. It's not just a belief that we're going to commit to. It's a case of like, well, how do we know that's a good idea? How do we know that this will be effective? The simple answer is show me. So for me, the idea is that the relationship between architecture is ongoing. We are always making decisions and revisiting them. That thing we thought committed to a year ago, you know what, that might not be appropriate anymore. Or now we've learned more, maybe this is going to cause us more problems in the future if we don't change now. So our vision of architecture needs to be much more fluid. Now, against that comes to the TDD alongside. These are simultaneous activities or simultaneous areas of concern and practice. And for me, TDD, going back to the sketching metaphor, it offers you the detail. So if I say we are going to organize our interfaces like this because it will be easier to test or because it will be easier to extend our code, that's a hypothesis. That's not a truth until we've established the truth of it. That's a belief. And an architect can say that to as many whiteboards as they like. But until somebody's tried it, we don't know if that's going to be, it's going to work out for us. So how do we know it's going to work out? Well, we could build the whole system and see how that works, or we could build a little bit and continue building a little bit and constantly look for that feedback. And so for me, TDD is the filling in. It's the feedback loop that tells me, and this is the important thing, going back to what I said earlier, to do this really simple task in this architecture requires ridiculous amounts of dependency activity. I need to call that. I need to receive that. I receive that. And before you know, you've mocked the mocks that mock the mocks that mock the mocks. And that tells you that's feedback on your architecture. And what your tests are telling you is this architecture decision is not good for this system. You need to think again about how you've organized things and separated things. So for me, architecture is, if you treat it as an abstract activity, you have a huge load of problems. If you treat TDD without understanding what it's feeding back on and what it's building, you will similarly have various problems. So there is a relationship between the two that I think is very well formed, but often overlooked. And we don't talk about it enough.
Right. Now, when it comes to scaling TDD in larger organizations, what are some of the most problematic challenges enterprises face in rolling out TDD across teams?
I think this one is more a case of, I'm going to say that although I'm very keen on TDD, I don't necessarily know that an organization wants to roll out TDD. It's a workflow practice, and I think if you can get that working within a team, that's great, but there's no reason that another team has to do it. And I think it might not be helpful for an organization to be mandating these things. I think what the organization needs to care about is more a case, not so much of the way that we are producing the tests, but the fact that, do we have builds that work together? Do we have comparable testing philosophies across different teams? If you've got a team that is just doing a more traditional kind of like test later towards the end of the sprint type approach, they're doing that, and let's say they're really effective and they've got some really good design and their interfaces evolve really nicely, and I wouldn't mess with that. They're doing a perfectly good job, and because we've organized it around teams, that doesn't really interfere as long as our teams have some kind of alignment and relationship with an architecture. Then I don't think there's a problem there to be solved. What we do want is the idea that we have a consistent or a reasonably consistent and compatible view of testing across the organization. If TDD helps me get that, then that's what I should be encouraging. But it's a case of, I'm not going to say that it's going to be the thing I should focus on. I think that an organization probably wants to focus in the organizational level is, if we have various build pipelines, do these build pipelines follow similar philosophies of testing? Because a build pipeline that doesn't have any testing in it is not really, it's certainly, I'm being very careful here. I'm using the term build pipeline because people will often say, oh, it's our CI/CD pipeline. But is it? Are you doing continuous integration? And are you doing continuous delivery? Is that because CI/CD is predicated on the idea that you have tests? In fact, to be fair, CI/CD is predicated, you are doing trunk-based development and you are doing a lot of tests. That is what that means. You can go and kind of look at the original books, and they're very clear on this. So definitely a lot of companies have build pipelines, but do they qualify as CI/CD pipelines? Not always, not from the strictest definition. And I think that's more valuable. So if we regard let's put it this way. I think it. I don't think an organization needs to worry about what people are doing in their homes, but they probably need to worry about the road system. So in this sense, organizationally, when we look at software architecture, we need to be thinking of software architecture more like urban planning. We want to have consistent rules and models for the roads. We want to have a consistent layout and see what the issues are and agree on things about roads and services, what people do in their homes and how they structure their homes and how they live with. I think that can be a lot more freeing as long as we have the knowledge available and maybe one team can coach another and we can say, hey, you can become our enabling team. We're going to try this practice. I think that's great, but I'm not sure I want the organization to get involved in some of the more detailed practices that support what goes on. I think what goes on and what the output is and how teams integrate is probably more important than specifically what they do on the inside.
Right. So let's say in cases where TDD is warranted, and based on what you've seen so far, what strategies do you feel can make TDD stick in the long run at the organizational level?
I think what can make it stick at the organization is kind of very much, let's build off what I've said. Is one of them is that a team needs to feel that it owns its practices, that teams respond and individuals respond sometimes quite poorly when they're told what they're going to do and they don't really feel it. And if a team is told you're going to do TDD, that's not a way of getting them to do anything well. It's a case of if they can make it their own habit, if they can create it if it's their decision, then that's really important. But also if they feel like they've learned something. And so again, this goes back to this idea of within any large organization. So this is obviously it's a question of different organizations and different scales. In any large organization, we're going to find that there are different kinds of teams trying to produce different kinds of products. And some people will say, oh, we don't do TDD here. Just be very careful that when somebody says we don't do TDD here, that's not also we don't do testing here. Again, going back to what we've already discussed, is what I hear when many people actually say we don't do TDD or TDD is not appropriate for us. They're actually using TDD to mean any kind of testing. And so therefore they're using the wrong word. They're actually saying something much more bluntly is we don't have tests. If they said that would be far more direct and we could work with that. And we need to work out whether that affects us or not. It's a team that's just prototyping and giving us the results of prototypes, then that's not important. If it's a team that's prototyping a design, yes, we want tests because you're telling us that this code, which we don't know whether or not it works, is the basis for what we're going to build. No, prototyping can involve TDD, and it can involve tests. I've done that a number of times in the past. So really, it's a case of trying to understand from the organizational level what how to get the knowledge out there and make the knowledge feel much more natural. So for many people, any kind of unit testing habit is the challenge. Having tests that run quickly is the challenge. And I would address these questions. I would treat those as the questions to address. And what we may find is that TDD, by example, may follow, particularly if we have somebody from within the organization who has experience of that, and that's how they drive it, and that's how they show it, and that's how they demonstrate it, then that may become a lot easier. Lead by example in this case, rather than by mandate. Basically say, hey, look, there's a lot of different testing workflows. Our objective is to get better testing, to make testing more convenient of any kind. I'm going to show you this. I'm going to use a test-driven workflow. Suddenly, when you do that's much more open, and I think people are more likely to adopt it. Whereas if we have somebody going around measuring different teams in a very obvious way, teams justifiably feel a little bit of resistance, offer a little bit of resistance there.
Right. So legacy code is a reality for most teams. If a team inherits a large untested code base, how would you recommend they approach introducing TDD or even more testing in that scenario?
Yeah, I think that's a really good one because that's going to be a lot of people's lived experience. So the point there is you got to prioritize. The first thing is perfect is impossible from where you are. So let's look at what is possible. And that's going to be a little bit different for each code base and each team. It depends on if you have a maintenance mindset it's going to be massively difficult to adopt TDD. And what I mean by maintenance mindset, and you might think I'm just talking about software maintenance. It's like, no, I'm actually using the word maintenance in its broader sense. It's like we're going to maintain whatever it is that we do. And maintenance mindset, you see often where, say, the development is, initial development's been done in one location and then it's been offshored to somebody else. And then these people don't think that they are doing software development. Often in places where, we're just maintaining it. It's actually, no, what you're doing is called software development. There's no real thing called maintenance in software. When it comes to products, it's all software development. There's not software development plus maintenance. It's software development. That's the proper words for it. So we first of all need to reclaim the right words. You are doing software development. Everything you do has the potential to change the architecture. In one sense, it is your responsibility not to maintain the problems in the existing code base, is to eliminate them. Maintenance is a stasis. You don't want that. Your job is to take it as being more ambitious. The job is to make this a better product than it was when we received it. How do we do that? Well, what are the obstacles? We'd love to test everything, but we have poor test coverage. Okay, well, let's not test everything. How do we prioritize what we are testing in that case? Well, first of all, there are a few constraints. If you find that much of the work, let's just say that over the next quarter, the next 3 months, we are going to do some work, we're going to add some features in a particular corner of the code base. And let us say that corner of the code base is already actually quite well isolated. Well, let's dig into that isolation and really reinforce it, really put interface, make sure we have automated refactoring tools, but even then we still have compilers that will still catch many of the type-based errors that we do. Introduce separations. This goes back to the code sense. If you have code that is tightly coupled, you can decouple it without actually doing too much changes that would rely on tests. You can rely on automated refactoring. You can rely on appropriate review. You can rely on lean on the compiler is what Michael Feathers calls it in his book, Working Effectively with Legacy Code. The lean on the compiler. And this is something I've done with a team. It's just like, okay, what we're going to do is we can ignore the rest of the code base, but we're going to make this really good. We can isolate it. Once you've got something that is isolated, it is easier to test because testing, unit testing, and even integration testing is about understanding isolation and improving isolation. And that's loosening of coupling and improving cohesion of code units. And these are the practices people need to really focus on to improve their code sense, understanding coupling and cohesion. I find these days that a lot of developers don't really understand what that means, and they become distracted by things that are not very good principles or not useful systems of principles. Like solid principles is not a coherent set of design ideas. It's just a bunch of things thrown together coincidentally, and it actually misses many of the things that are actually important from an experiential point. So I'm going to get comments for saying this, but I've been doing this long enough that I can actually say solid principles are next to useless if you want to learn how to write good code. Learn the fundamentals and reinforce those. And if you're able to isolate a little piece of the system, then that becomes the area that is your new development. We see this going back to urban planning. So we see this sometimes in cities, we can't change everything, but we can change something. And this area is really good. And because it is separated, we have some benefit there. So that's one technique for basically allowing a team to claim territory and improve not only the testing, but the design. The idea is we're not just improving testing and testing habits. You're actually improving the code. These are not separated activities. And I think, again, that goes back to the misconception of treating testing as some kind of separate idea, and tests are separate. They're not. They're showing you how the code fits together and whether or not your design is good. So if you're saying testing is difficult, you're saying the design is difficult. Great. What do we do to change that? If our belief is that our job here is to allow us to have put this way, you should always make it your goal. My goal is in 6 months' time, it should be easier to work on this code base than it is now. What does that involve? That's not just going to involve testing. It's going to involve changing the code, changing aspects about the build system, all kinds of little bits and pieces. So the idea is what you're trying to do is improve that. But the other way we can do this is to ask the system itself. Treat the system as having a body of knowledge and let it prioritize things for me. If I can't, if I've got a million lines of code, I can't change that. A team of 10 is not going to be able to transform a million lines of code overnight. So don't, but ask the system. This is the benefit of legacy that we often overlook. A legacy system has a history. Look at the history. What's changed? What keeps changing? Look at the code that keeps changing the most. Okay. Doesn't matter if it's for a good reason or a bad reason. If it's frequently changing, that's where you want to try and improve things for testing and for the developer experience. Because if you're frequently changing something, you're more likely to break it. If you're frequently changing something, you're more likely to benefit from having that be better. Yeah. Stuff that is incredibly stable doesn't need the same attention. That doesn't mean it's automatically good. I mean, sometimes things are stable because they're absolutely terrible and people are frightened of them. But the idea is you don't need to touch that because whatever it is, it's no more broken than it was before, or whatever it is, it already works. So, in other words, use the system to tell you what to change. Your system already has an opinion of this. Do you have a heat map of where your defects are? That's where you want your tests. So the point there is you can use the legacy nature of a system constructively and positively. And I think we often overlook that because it's not immediately obvious.
Right. I think that's a really rich set of techniques and best practices you've given us for brownfield projects. Now, you've worked with a variety of programming languages, from C++ to higher level languages like Python. Do you find that TDD plays out differently depending on the language or tech stack?
Yes, it does, but not always for the reasons that people think. Sometimes it's a cultural thing. What I mean, just as in the real world, languages are associated with a culture. There's the syntax of a language and there are the availability of certain tools. So culturally, for example, you tend to find that developer testing is far more prevalent in Java. And there's actually not anything specific about the language that makes it more amenable to testing than, say, a language like Python. But testing is more likely to be there. Why? Because that's where modern unit testing grew up. The JUnit framework appeared in the late 90s and was integrated at that point with Eclipse. And then it became normal to integrate unit testing frameworks with IDEs. And Java was the language where these practices and these cultural habits were first formed. So Java developers are much more likely to get exposed to things like JUnit in an integrated environment early. So yes, in that sense, Java is better suited to this than, say, Python, because Python there isn't a standard IDE these days. You know, if you're working with Java, the chances are you're using IntelliJ. If you're using Python, then you are coming from a number of different places. If you're a data scientist, you have a very different view of the world. You know, data scientists don't generally use Java, but a language like Python, you have people who consider themselves software developers, you have kids who learn it, you have people who are just using Python for scripting, you have people who are using it from a data science perspective. You have all kinds of people. There isn't necessarily a single core to the culture. And so therefore you end up with disparate practices. And Python came along before testing became a strong habit. Now, this is not to say that developers don't do testing, but Python developers don't do testing, but it's not about the language features. It's more to do with the culture in which people find themselves in, and therefore the developers around them and the information available. So in that sense, there's an obvious difference is the development culture associated with something. We go to C++, let's go to C for a moment, and C is much more likely to be kind of classic systems programming, embedded programming as well. These are cultures where you don't tend to find things like unit testing. If they're testing at the system level. They're not even necessarily testing at the integration level. And they're not even necessarily testing in the code. So culturally, that's the obstacle. But then we also find design habits. And this is where the language starts becoming relevant. Python is a much looser language because it just is. It's a dynamically typed language. And so therefore, it is actually easier. I sometimes joke that if I'm using Python, I don't need a mocking framework because Python is the mocking framework. You know, mocking frameworks were invented for statically typed languages. They come originally from Java because you're trying to work around the fact that the language doesn't work at a meta level. The language is not kind of like elastic and plastic and easy to reshape. Whereas in Python, I can reshape almost anything. The language itself is a tool at that level that can be used to modify itself. So at that level, Python can be easier to test from that linguistic perspective. But there's also cultural habits that can sometimes get in the way. Python developers have a nasty habit of always putting files everywhere and accessing files in every single function. They're more likely to do that, particularly in more data sciencey kind of uses. And that's a habit I try and encourage people to stop. So there's design habits that can prevent you. In C and C++, there are constructs in the language that cause longer build times, more source file dependencies, but also there are habits of design, particularly prevalent, that don't lead to natural decoupling and points where you say, oh yeah, this is really easy. I can just substitute something in right here because the design already allows it, because that's our design culture. And so therefore you have to kind of go uphill a little bit against the prevailing culture of the code base. So I do think the languages make it easier or harder, but only sometimes is that to do with the language itself. In many cases, it's to do with the culture, the design culture, or even just the testing culture that exists with the language and around the language.
Right. The quality of tests is crucial in TDD. What are some best practices you recommend for writing good tests in a TDD cycle?
That your tests should. So one of the techniques that I always think of is that your tests should be testing one concept, one idea. That doesn't mean they have necessarily just a single assertion, but they should have a single focus. What is the thing that you are trying to demonstrate? And that should be easily summarized by the test name. This is one of those cases where naming something is not merely labeling. It's actually testing is design in this case, because it will cause you to create different tests if you use a different design approach or different naming approach. And my preferred habit is to use tests that are propositions. So let's just take this cup, for example. Some developers might go, oh, I've got a constructor, and they'll write a method, test constructor, and test fill or test drink. And what you're doing is you're just going through the shopping list of methods and writing a test for each method. You can't test like this. There's no way to produce, and I actually do this when I run training courses. I show people it is impossible to produce good tests using this technique. If you just go one method at a time and say, I'm going to write a test for this method, you cannot write good tests for that. Partly because in order to drink from a cup, I need to create it. So therefore I've already involved the constructor. So I'm not just testing the drink method. Oh, but I also need to fill it. So I'm using the fill method, and then I can drink from it. And then I need to determine whether or not it became empty. I've just used 4 different operations there. I'm not testing a single operation. I'm actually testing the interaction. So this is why when we look at the perspective from BDD, behavior-driven development, that gives us a different way of understanding what you're after. You are after testing the behavior. The behavior is not just in a single method, it's the composition of different methods in different scenarios. But another reason you don't end up doing test drink, for example, is that I can drink in 2 different scenarios. I can drink from an empty cup and I can drink from a full cup. That's not one test case, that's 2. They're very different. They have different outcomes. So the first thing is, if you are currently, so it's a huge test smell. If I just see tests that are just, here's a method, here's a test method that corresponds to it. A, test A. B, test B. C, test C. You don't have the test. It's as simple as that. I always lay it down as a challenge to people. Show me if you have any counterexamples. Nobody has ever been able to come up with a good example that contradicts that observation. So what you need to be doing is testing behaviors, or in some cases we would look at it as testing a property. There's a fluid overlap between these approaches. And to make a statement, a propositional statement. By a propositional statement, it means that we describe something and the way that it is. A new cup is empty. Drinking from a full cup empties it. These 2 sentences are the test names. Okay, so literally your test name should be as easy to read as if they were specifications, which is what I said earlier. In other words, each test needs to be organized and thought of as a specification with an example. Here is the thing that we are showing. This is the expected outcome in this scenario. Okay, this is the behavior or the property that we are entitled to and are requiring at this particular point. And when we start looking at it like that, you suddenly realize your tests are not just a bunch of assertions with bits of setup. You're telling a story. You're describing the system from a specification oriented point of view. You're giving people a series of logical propositions. If the test fails, if I say a new cup is empty, that's a proposition. If that test fails, what does that mean? It means a new cup is not empty. I can tell immediately by looking at the test name what is wrong. I might not know why, but I know what. Whereas if I say test constructor and that fails, I have no idea what that even means. So the point is your tests are units of meaning. Or put another way, they're not just verification, they're communication. You're communicating actual meanings. So if you're testing philosophy, you're just poking your code to verify it, you're going to end up with, test named after it, or even worse, I've seen this a few times, test 1, test 2, test 3. Honestly, that really isn't going to help anybody. And it's those kinds of tests, you can always tell whether or not a team has really understood or has a good testing habit. Because if they're testing like this, there's no way they have a good testing habit. They're doing testing as an afterthought. It doesn't feel good. I wouldn't like to write tests like that. And if somebody say, Kevlin, why aren't you writing tests? I'm going to say, well, because it feels wasteful and it's annoying. It's frustrating. And yeah, if you adopt those practices, it is annoying. I wouldn't want to write tests like that. So the test quality needs to be quite high. Otherwise, you're going to end up with unmanaged technical debt in your test base, as well as problems in your code base. You don't want to double your problems. You want to reduce them. Your test should be a clear explanation of what your system does in the detail, along with intention. So for me, that is what I put under the heading of guts, good unit tests. And that's a term from Alistair Coburn, is that a TDD doesn't miraculously cause you to do guts. You need to, again, you're in the driving seat. Having a nice car does not cause you to be a better driver. And I think there's a lot of people who would benefit from that knowledge in the world, just generally as drivers. But just because you have a TDD, you're doing the test first workflow, doesn't mean you're doing good stuff unless you bring something else to the table. You have to bring something else to the table. That's your design sense, your test sense, the idea that every time you're writing a test, you're trying to describe something that you want to have existing in the world. You're specifying something. So if you have a good specification mindset, you're going to find that really easy to integrate. If you stop thinking about your test as verification, you are specifying, you are communicating your intent. And when you do that, your tests immediately benefit. But more importantly, so does anybody reading them. And that suddenly becomes a key improvement.
Is there anything in addition to what you've just said that developers can sort of employ when they're handling aspects like mocking or stubbing or testing private or complex behaviors?
Yeah, I think, again, it's one of these ones is, to borrow a term from Kent Beck, he always talked about listening to your code or listen to your tests. If you feel that you want to test something that is private detail, let's say you have a large class and you're saying, oh, there's a lot of intricacy and complexity going on inside this that I cannot see through the public interface, and therefore I would like to test that separately, then the listen to your tests. What are your tests telling you? Your tests are telling you this is not cohesive. You've got everything is like bound up. You've got too much in one place. If you want to test a behavior or a related group of behaviors, then that related group of behaviors is its own module or its own class. Why is it hiding inside another class? So in other words, this is design feedback. Again, it's this idea that sometimes the difficulty of testing comes from the difficulty of the code. So I would say listen to your tests, and therefore, but my standard answer is when people say, how do I test the private stuff? My stock answer is, generally speaking, you don't. That's a signal that you need to separate something else. You need to separate something out. You're not dealing with one idea, you're dealing with two ideas. And one of them is hidden inside the other. Pull it out, do an extract class, and focus on that. It's clearly important because you value it. You've just said, I want to test these behaviors. You probably even have words and names for it, but it's hiding embedded inside another class. So give it first class citizenship and extract it. Now, at the same time, I also recognize that there is a point here. If I told you that and we've got a major release tomorrow, that's probably not helpful advice from me. So that's why I don't say do not test, or you should never test private stuff. What I say is that you should take it as a signal, and you probably don't want to do that. So therefore, what I would say in that case is, in those cases where we need a little pragmatism, go like, yeah, okay, I'm either going to weaken the encapsulation on the class in one way or another, but I need to put a huge, great deprecation, or, this is technical debt. I need to manage that in Jira. And if I've ignored that warning 3 times, take it as a 3 times and you're out rule. If I keep coming back to the same code, me and my colleagues keep coming back to the same code and say, yeah, we said we would. You need to properly schedule that as a piece of work, because you're always working around it. You're not working with it. You're not working with your code. You're working around your code. So that would be something I would say. And again, that's not really so much a kind of a tooling thing as understanding what your tests are telling you. When it comes to mocking, I don't have any strong opinions, except that most people mock too much, rather than understanding that excessive mocking is an indication that you have a problem that you should be solving. Don't lean into it by adding more mocking. Lean into it by asking a different question. How do I mock less? What rearrangement of interfaces or class responsibilities would make this easier? I generally think that people use too much mocking anyway, even in quite good designs. There's actually simpler ways of looking at it, and they confuse themselves. So you end up with a lot of mocks and a lot of mock noise, which is not to say that mocking is not useful. It's just that most of the time, I think the guidance I gave to one team is years ago, if you're not mocking, you probably need to learn how to mock. But if you are already mocking, you probably need to learn to mock less. But I don't have any specific feedback on mocking tools, except to say that sometimes I don't find them particularly necessary because of the language. I made the comment about Python earlier. But in other cases, testing frameworks, my general guideline for that is, I do have some preferred frameworks. If I'm working in .NET, then NUnit I think is one of the best unit testing frameworks in the mainstream for any language. And so I tend to always encourage that. Unless you need the features that TestNG offers specifically, I think you can do better structured testing in JUnit 5. I generally lean towards that. The story was different when JUnit 4 was prevalent, and TestNG had some things that JUnit 4 didn't have. If you're working in the C++ space, then I generally consider that Catch framework is the best one. I do occasionally have various remarks about things that I consider to be legacy. So in other words, but the general advice I would give you is, if you are a team that is looking to really commit more to testing, look around you. If you're in a large organization, you're not the only people who are doing this. Take advantage of other people's knowledge. If there is another team there that is already doing something, and they're using the same tech stack as you, start with what they've got. They've done the hard work, but you can also ask them. So take advantage of existing knowledge. But the only boundaries I would have on that is, if you're in Python and you are using the unit test module that comes with standard Python distribution, please don't. It's just not a very good testing framework. Please use PyTest. I would make that recommendation. If you're in C++ and you are using CPP unit, please do not use CPP unit. I've been cautioning against using it for about 20 years. It's just not a very good unit testing framework. It's an interesting starting point, but it's just not a great unit testing framework. If you're in C++ and you're using Google Test, recognize it's a legacy testing framework. That is a testing framework from the late 2000s. That's over 15 years ago. It's really not very good at certain modern practices. That's not to say don't use it, but recognize that you're using a legacy testing framework and work out what can you do that would improve things, and so on. So find, balance between where can I get the knowledge locally, but also, am I using something that's genuinely legacy that should be retired and we should have nothing to do with, and work in that space?
Right. Does tooling make or break the TDD experience?
That's a very good question. I think I think it is easy to say that it can completely make it. It's also easy to say that it doesn't make any difference. I think a better way of looking at it is that sometimes people do get wrapped up in the idea of, it's about my framework selection, it's about my tooling selection, and that's understandable. We're in a business where tools and technologies matter, but at the same time, the real experience, most of what you're going to get, comes from being able to create the workflow. Okay, and So if you're able to establish the workflow and the code that you're working with has the right properties, or you're moving in the direction of it being loosely coupled, highly cohesive, you're using good classic design practices to organize your code, then you're going to get most of the experience that you need. And that won't change too much between testing frameworks. But I used to, a technique I used to use years ago is that I used to get people initially testing with just plain asserts, just a straight assertion, whatever is available in the language or library, without using a testing framework. And then I would get them to refactor towards a framework. Now, this actually turns out to be quite useful. One company did this for their C and C++ code, and actually created a framework that they then controlled, which is very useful for their embedded environment. It's not something I ever really did with the Java folks, and I occasionally do it. Sometimes a bit of fun with Python, but not very much anymore because these are solved problems. But it was to really show people that, first of all, there's the fundamental ideas in a testing framework are not too complex, but also that you'd be surprised how little you need to get a testing workflow. But that said, I like to be able to have a testing framework that supports a number of basic features. Obviously, when a test fails, I want to continue with the rest of the tests. I want to be able to have parameterized tests, so my tests can be data-driven. Any testing framework that doesn't support that in 2025 is kind of like it's an interesting beta, but it's not yet a proper testing framework. It's a kind of like a 2000s testing framework. I like to have a testing framework that allows me a way of organizing and grouping tests easily. These just streamline the overall testing experience, but also they allow you to have more expressive tests. Whether that makes or breaks, I don't think it's quite on that, although I can imagine being sufficiently frustrated in some cases that it would break. But I think it improves the experience dramatically. And if you get a better experience, you're going to do more of it. So I think that there is something to be said from that point of view.
Right. And is there a specific tool or framework that you personally like using for TDD specifically?
I've kind of mentioned them already a couple of times. The ones that I think flow best for me, and again, obviously you have some of these are going to be a matter of personal experience. But if I'm JUnit 5, if I'm using Java, and that's actually a little bit different to JUnit 4. I found JUnit 4 kind of got in my way a little bit, but JUnit 5 has just enough that allows me to be that I'm not working around the framework. I mentioned Catch for C++, and I would also encourage the use of Catch for C. In other words, if you're in an environment where you're doing the production code is C, do your testing in C++, because the tools are generally more powerful. I mean, that's a common pattern anyway, but okay, I would use Catch there. It allows you to be much more specification oriented, and there's no surprise if I say, yeah, I'm more comfortable using Jest with TypeScript and JavaScript, and with C# I've already mentioned NUnit as being the one of choice. Occasionally I will do stuff in languages where I have less familiarity with frameworks. I did something for a client a couple of years back in Ruby, and we used RSpec, and I was quite impressed with RSpec. It had been years since I'd used it. I found it still a little bit limited in some senses, but I also found that I could create some really nice testing approaches in it. But my opinions on that and others are slightly less strong. But yeah, I think those are the ones that normally stand out. And there's nothing unusual in that list, I don't think.
Right. Thank you for that. Putting TDD in the context of overall testing, how does TDD fit with other testing practices on a project? You've talked about it, and you hinted at this briefly throughout. But if we were to just focus on this aspect.
Yeah. I think normally when we talk about TDD, we normally lean towards the unit test thing because that gives us the fastest feedback cycle. And there is no single standard definition of what a unit test is, but the one that is perhaps most widely used and most widely accepted is really very much about the isolation of, can I isolate a piece of code from external dependencies, external runtime dependencies? Okay. And the answer is yes, then that's a unit. It's not about language constructs. Is it a class? Is it a module? Is it a function? Whatever. It's about isolatability and the idea that I'm not going across a significant boundary of communication. Yeah, I'm not hitting the file system. I'm not communicating with another service. The idea is that I am contained, and therefore, as a nice consequence, it's going to run fast, but also you control everything about it. Okay. You don't control the file system. You don't control the network. Those are outside your control. They may be perhaps under your influence, but not your control. So if we define the unit from that point of view, then we get fast feedback cycle, and it's telling us something about the internal structure and looseness of coupling and cohesion, the strength of cohesion of what we're building. So from that point of view, it feels like TDD is very much in the unit testing space. But that said, exactly the same workflow works for integration tests. There is nothing different to that. You can use the same workflow. All of the same test recommendations pretty much apply, but I will probably be using other aspects of my unit testing framework. For example, if I can pull in data files, for example, then it starts becoming a little more serious. It just means that when a test fails or when a test passes, I cannot guarantee that the reason it passes or fails is just to do with correctness of code. Okay, if your network's down and what you're testing involves wandering across the network, your test will fail, and it won't be to do with the fact that your test is wrong and your code is wrong. It will be to do with the fact the outside world is wrong. So, it's to do with the nature of feedback, and it will also be a bit slower. But everything else about it, the sensibility, the mindset, the structure, the naming, the partitioning, all of these other things, they're kind of the same. And then we hit things like acceptance test-driven, ATTDD, which I always find difficult to say. It's a lot easier to write it down, but acceptance test-driven development, where we're actually looking just beneath the UI skin of an app. So very much potentially end-to-end without UI interaction or integration, higher-level integration. But the idea is it's still code on code. And we're doing that. And the idea with that is that clearly the steps, the small iterative steps, they won't be as small. They're probably very much more at the feature level. We're looking at not minutes and minutes to hours, but hours to days before a certain test may pass, and that's okay. But the same sensibility applies. And this is also where many people will associate behavior-driven development, although behavior-driven development is a philosophy that also applies to the unit tests. For many people, they think of BDD in this space. I'll be very careful to say it's not just in that space. It's just the way that many people approach it. But again, that can lead you to structuring your workflow in this same way. So you can see there's a sympathy between many of these kinds of testing. In terms of scale, moving up the testing pyramid, we end up with the same kind of philosophy, but perhaps our feedback cycles become larger. But we can also look at other forms of testing. So contract testing is where we would say we're testing external, historically what I call conformance testing. For me, contract testing is what you always do, because you're testing the contract of a class, you're defining it. So it's not about third-party code. But the term has come to mean code that is external to the code that you're writing, and you want to test that it conforms to your expectation. I think that's a really important point because it's complementary. It's not the same. And it addresses an issue that sometimes people have when they're writing TDD, and let's just say, I don't know, let's go back to my cup. Let's just say I'm using somebody's cup framework that I've got from GitHub. I'm using somebody's cup framework that's going to enhance this. And maybe I've had some bad experiences with that framework in the past. And there were some bugs in that framework. And the problem is that's going to give me, that's annoying because I'm trying to focus on my code, but I'm discovering bugs in somebody else's code, in third-party code. So maybe I put an extra little test in my tests just to test that bit that broke before doesn't break again. And so you end up with a lot of tests that are drive-by tests. In other words, it's just like, well, I'm testing your thing, but I'm also testing this other thing. Don't do that. Your test has now got mixed responsibilities. You want to separate that. That's where contract or conformance tests fit in. The idea is that you want to basically say, everything we depend on that might cause a problem, we have got tests that check that. If those tests fail, we don't even bother running our tests because there's no point. If the foundation of what we're building on doesn't work, then why are we even going to bother testing our code? Because it's, the foundation's already broken. So the idea is that's a clear separation. That's written in a much more what we might call defect-driven style. rather than test-driven style. Hey, this isn't working or was not working historically in that, so I'm all right to test for it. So just to make sure the latest version or the versions we use in future are always working. Or where we want to have a clear characterization and we're doing discovery of how another API works, take advantage of write tests for that discovery so that you've now got those characterizing tests. So that complements our core tests and our core workflows. But we may also have other tests like performance tests. Now, performance tests are typically going to be something slightly different because they're more, they follow different experimental design. They have a different workflow in the sense that if I've got a transaction, if I drink from a full cup and it doesn't empty it, then that's a bug straight out. But if I say that we have a particular availability or there's a particular performance limit that we've got, then statistically you may find sometimes when we run the test we pass, sometimes when we run the test we don't because of the way the operating system schedules and so on. We're not really dealing with something that is about true and false. We're dealing with something that is better and worse. And there's a kind of a gray area. And we really want 90% of the time to be in this performance space. And we'll tolerate 10% in this case. That suggests that the nature of our test requires a different philosophy. We can pass and fail at certain limits, but it's not the same way. And we don't just run it once and say that passed. We need to draw from different samples, sometimes scaling-based samples. So those tests feel very different in that sense. And again, they're complementary, but not in a way that fits with our TDD. In a way that's actually quite separate. They are testing behaviors that are outside the basic semantics. They are testing performance characteristics and so on. And that requires a different mindset, I feel.
Right. Now, from a team leadership perspective, how can leads or senior devs encourage the team to stick to TDD when deadlines are tight or, like, as you said, people feel tempted to just code it and take it later?
Yeah, I think the thing is, again, it comes back to whether or not it's your idea or not, whether or not you feel you own that idea. If TDD is something you only do when the team lead is in the room, the minute they walk out of the room, you stop doing it. You don't have your team's not doing TDD. It's kind of performative TDD. You're doing it because you're supposed to. And that's that sense of obligation, which means that the minute you feel any kind of pressure, you're going to just throw that out the window. And we see this with a lot of different practices. It's not unique to TDD. The point there is that you need to somehow get to the point where it's a habit. You embody it. This is what we do. And also, if you have enough experience, you start realizing that the minute you start throwing out certain disciplines, you are going to pay for those later. This is where our managed technical debt comes from. It doesn't come from some kind of magic genie that pops into your code. Well, actually, no, maybe agentic AI can reduce the quality of your code while your back is turned. But the point there is it doesn't magically appear in your code. Oh, where did the technical debt come from? It got there for a reason. And the point there is that people very love to say, oh, these practices only work at certain cases. Like, honestly, there is a truth to that, but the chances are that whatever you're working on is not so special that whatever practices you find normally useful, if you're already finding TDD useful, if you're not, then that's a different discussion. But if you're already finding TDD useful, lean into it a bit more. But from the team lead perspective, the case there is the job of curiously enough, is the job of a team lead is not to necessarily is not a controlling role. It is a leadership role, and leadership is not about managing. It's mostly about example. It's about enabling. It's about making people, show people opportunities and make it somehow easier for them to try the right thing than to try the wrong thing. And in some cases, TDD may be a good thing for them. That's great. How do we make that feel like it belongs to them and it's their practice, not the team lead's practice, not the organization's practice? How do I make it my practice so that when I start on a new team, that's how I do things? That when I go for an interview, that's how I say things, because it's my practice, not the team's practice, or the organization's practice, or the team lead. This is not a practice that belongs to that person or that entity. It's my practice. So for me, I think that's the skill, which means that there isn't an easy answer, I'm afraid, if anybody's watching and is hoping for an easy answer. Sorry. But that's the skill, but also the subtlety in that. So I would look at it from that point of view.
Right. And now we are, at the big question.
Yeah.
AI, about AI. AI can draft tests fast, but quality is debatable.
Yes.
So, according to you, what acceptance gates would you require so that you can increase false detection for tests when using AI?
I think the first thing I'd even take a step back before that is to understand if you're using AI, why are you using AI? This is not a doubt about AI. It's just that most people don't know why they're doing something. Why are you using AI to generate tests? What problem are you solving by doing that? And most people can't answer that question. So immediately you know that you have a problem. We're using AI because we were told to use AI. Hey, guess what? We're right back at you were told to do stuff. This isn't your practice. This is somebody else's practice. But what problem are you trying to solve? And for many people, it's like, oh, we don't have many tests. Great. So now you're going to generate lots of tests. And do you understand those tests? No, we have no idea what they're testing. You don't even know if they're right. So by coincidence, yesterday I published a blog post called "Think for Yourself," which was actually it was generally about dealing with LLM generated code. It wasn't specifically about TDD, but I basically gave people 4 things to consider whenever they're going to integrate anything that is AI generated. The first question is, does it work? I mean, does your code work? Do your tests work? Are your tests testing the right thing? Second question is, do you understand the generated code? Okay. And if you don't know that something works and you don't understand the generated code, you need to step away from that AI generator really quickly, because you are not helping people. You are creating problems. You are going to create a lot of busy work, and and sometimes people, oh, it's boosted my productivity. Most people who say that AI has boosted their productivity, I have really bad news for them. The numbers do not match up. Some they do. Some people absolutely, they have a really good understanding of what it's doing for them, and they are doing a really good job. They are using it for benefits. But most people are just under the illusion that being busier is a good thing. Hey, I generated lots of code. Oh, what did you do the rest of the week? Fixed it. That is the worst case to be in, because what you've done is you created legacy code. Because one of the definitions people offer for legacy code is, I do run workshops on legacy code. And one of the interesting ones is, what is legacy code? And there's no perfect definition. There's no unique definition. But one of the definitions people often give me is code written by somebody else. That's exactly what most AI code is. Now, I'm not saying you shouldn't use AI code generation. What I'm telling you is good use is going to come from understanding, first of all, does it work? If you don't have a way of doing that, the number of times I kind of been partly full or could have been fooled if I did not have tests. So I write my own tests. I don't trust. The point is, why is an AI going to do better tests than me? Because I'm going to have to explain myself to it. In the time I've explained it, I could have written those tests, and I know why I've written it, and I've made certain design decisions. So the point there is that AI might be useful for generating certain coverage tests in bad coverage situations, but I also have questions about that. If I am using it to do that, if I am generating tests as well as generating code, I need to spend most of my time reviewing. And that's a skill that most people don't have. Most people don't know how to review. I spent years learning how to review, prose, fiction, fictional prose, non-fictional prose, so technical writing, books, articles, code. Reviewing takes a lot of practice, and most people just like, oh yeah, I look at it and then it looks good to me. And it's just like, that's not going to get you very far. If you don't understand the generated code, then you have a problem waiting to happen. But also, and here's the cool bit, you can learn from it. So if you're using AI generated tests, do you understand your code? What can you learn from it? That's a really important thing. If you're just going LGTM, dumb, it doesn't matter what it looks to you. You don't know enough to say that it looks good to you. And then there's the other thing is that now is take control. What's the difference between the generated code and what you would have written? If you were to write that test, what would you have done? Now, they're going to be different, probably. They might be the same. And what I found is understanding the difference between what's been generated and what I would have done is an education. Sometimes I learn something new. I think, oh, that's a really good way of doing it. In other cases, I look at what's been generated, it's like, that's not a very good way of doing it at all. Either way, I've now understood something. And then the final recommendation is, can you think of at least one way to improve what's been generated? In other words, this is net so, and then make it so. So for me, there's these two parts. One is, why are you using AI to generate your tests for you? Do you actually have a clear understanding of what the benefit is? How are you going to measure that benefit? If you don't have that, don't do it. Okay. You're not being busier is not productivity. Okay. The next thing is, if you are doing this, whether it's code, production code or test code, is that list of form. Does it work? Do you understand what you've got? What's the difference between what it's done and what you would do? And can you think of at least one way to improve it? If you do that, you are going to learn so much. You're now using AI as a possibility generator, and you're also interacting, and you are passing judgment. You're using your design sets, and you're either accepting because, yeah, actually that is good, and I know why, and I can tell you why, or you're changing it because you go, it's not good, and I know why it's wrong. And I'm going to fix that. I'm going to improve on that. But either way, you've made it your code. It's no longer legacy. You're actually using AI properly as an assistant. Yeah, we use the term AI assistant an awful lot. In most cases, it's not an assistant. You're not enabling this. So for me, that's the general advice is many people are being backseat drivers when it comes to their use of AI. And they have no idea what is being generated on their behalf. They don't understand what is being tested. When they have to fix an issue or address a piece of code, what they discovered is that they don't know enough, and it now takes them longer to address, and they are not using it. They're not using the right part of it, as it were. They're not using the power that they could do. So in other words, be very clear why you're doing something, particularly when it comes to tests, because for me, I think that not writing the tests is actually where your strength lies, or rather, you writing the tests and not having the AI do them for you is where the strength lies.
Yeah.
Because going back to what I said earlier, how do you know the tests are any good? Do your tests look like the smelly tests that I described? They just test a method. The point there is you need to be making the decision. And if you say that's going to take a long time, the answer is you have no idea how long it's going to take, or rather, you have a very bad sense of time. And I'm saying that because I know this is a general truth. Humans are very bad at managing time and perceiving time. So the point there is, your test, and this is actually a way you can do TDD, by the way, with AI, is that you write a test and you get the AI to generate it. Here's what I want. This is what the code looks like. I want you to generate something that passes all of these tests. And my name is so clear that you should understand the intent as well as the example. That example needs to work. And you are taking a specification-driven approach. Okay. Now, you might do that. You might choose to take a step further back, specifying in a non-code language at this level. Fine, but sometimes the precision required is almost exactly the same as the precision required in code. So be careful that you don't fall into a false economy there and a false misunderstanding. Working in English is not always a higher level of abstraction. Sometimes it's just more words. Sometimes we write things in code because it's less. Certain business rules look shorter in code than they do in English because English is a general communication tool. It's not a specification tool. You have to put a lot of work in to make it a specification tool. But the point there is, whichever way you're using it, make sure that you're the person who's driving it. Yeah. If you're just the passenger, you're in for a rough ride.
You're going to get into trouble. Some really great advice there, Kevlin. And now for the final question, and it's time to make some predictions. What do you see as the future of TDD and automated testing practices? Are there any emerging trends, perhaps in tooling or anything else that you believe will shape how experienced developers approach TDD in the coming years?
Well, this does follow on naturally from the AI question. I think that first of all, let's consider automated testing generally. I think that the advice that we offer people is like, hey, you should test your code. It was always true. It's now even more true. If you are using AI code generation, then you really need to know how to test your code. If you don't have, if you don't already have an automated testing habit, now is a really good time to start, because you will find that generated code sometimes fails in ways that are intuitive, and humans would, oh yeah, I can see how that mistake happened. In one sense, that's not surprising given the training data. But in other cases, there are mistakes that are made that you go like, why would you ever make that mistake? So sometimes the mistakes are very sympathetic and understandable, and other times they are really different. You need to get better at testing. And that that's one of those. So this is the interesting thing, is I said this in 2016, 2017, before we even had LLMs. I was asked a question at a conference, MobiConf in Poland. And it's actually, there's a video online. It's one of the questions I basically say, future of AI, people are just guessing at that point. And I basically said, you need to get better at testing. That's the thing. So the point there is, I don't want an AI anywhere near company critical code without tests and without proper reviewing skills. So that it's not a testing skill, but I'd say the other thing you need, get good at testing, really get good at reviewing. I mean, as in, you need to improve your design sets. You cannot review code unless you have deep design experience, which means you also need to learn to code. So coding is still relevant, because otherwise you don't know what you're looking at. And that's not about language tricks. That's genuinely about familiarity with a kind of precision that you don't get outside code, or rather you do get, but you have to go into science and mathematics for that kind of precision. So the point there is, these are the skills you really want to have, and they sit with, as far as I'm concerned, they are in the same space as the precision and specification thinking you need with testing. In terms of the actual workflow of TDD, I think it's difficult to say at this point. I think that TDD adoption is always going to be relatively low compared to, as the industry stands, most people don't test. And then there's a significant and increasing proportion of people that do test, and that has been changing, and we can definitely see the needle has moved on that over the last couple of decades. And then within that, there is a proportion of developers, a much smaller proportion of developers, who will do an experiment with TDD or have TDD in their kind of toolkit, and they can employ it. I would like to think that number is going to go up, because I do actually think that with just leaving AI out of it, I do think it's a good practice, and I have thought that for a long time. It's a helpful practice to have. It encourages a certain incremental thinking. It encourages clarity, and with the right sensibility, it leaves behind something that is worth leaving behind, rather than something that people will curse you for. If you are working with AI, then again, those same things are valuable, and I'd like to think that it might even improve or sort of shift the uptake, increase the uptake of TDD. But I think that's difficult for me to predict at this point.
Right. Some really good things to, dwell upon there. And that also brings us to the end of our conversation today. Kevlin, thank you so much for joining us and sharing your insights on developer testing and TDD, why adoption stalls, and your perspective on tooling, culture, and the road ahead with AI and property-based techniques. It was really invaluable having this conversation with you. Thank you so much for your time.
Thank you very much.
And to our viewers and those listening to the audio version, thanks for tuning in. If you'd like to go further into the topics we covered, do explore Kevin's talks and writing and his contributions on the Modern Software Engineering channel. We'll add the links for you in the description below. Until next time, this is Divya for Deep Engineering.